All right, so we got 4 warm-up problems today. The first 2 are differentiation. And again, these are both Chapter 7s in the Stewart book. E to the x, derivative is e to the x, and derivative of ln x is 1 over x. So this is a chain rule. Derivative of y is y prime. Derivative of e to the x is e to the x. Then just do the chain rule. So everybody, that's the answer to the first one. It's just a chain rule, right? On the second one, take the derivative of both sides. Derivative of ln x is 1 over 2x to the 5th times, okay, derivative of 2x to the 5th is 10x to the 4th. Now, I might have left the other one, but this one we got to simplify. You guys agree it's 5 over x? Now, everybody, I'm going to show you through the limit laws, which I don't expect you to do. I think this is the better way to do it, but I'm going to show you through the limit laws and the log rules and pre-calculus how else this could be done. Because when we look at y equals ln 2x to the 5th, we should be thinking to ourselves, well, I could write this as ln of 2 plus ln of x to the 5th, right? Remember when you're adding exponents, you're multiplying bases, so I'm just going backwards. And then we could bring it down, right? We could say, oh, hey, this is ln 2 plus 5 ln x. All right, and if I take the derivative of the green, y prime, derivative of ln 2 is 0. 5 is a coefficient. Derivative of ln x is 1 over x. So y prime is 5 over x. Everybody, obviously the same answer has to be. You guys agree? But it doesn't matter what method. I think the red is substantially easier than the green. But we had these rules in pre-calculus that we learned for this reason. Okay, and when we want to do difficult derivatives, we'll use the ln or log method. Problem 3. For each problem, find the value C that satisfy the mean value theorem. Well, it helps if you understand the mean value theorem, and I'm going to take 2 seconds to talk about before we do the problem. The mean value theorem states for some curve that I can find the average rate of change between 2 points, the secant line, right? And that somewhere along the line, the instantaneous rate of change is exactly the same. In this case, I can find, on the one I just drew, there's a bunch of places it's the same. It's the same there. I think it's the same here. I think it's the same somewhere up in here. There could be multiple C's. All right? So that is the mean value theorem, that the instantaneous rate of change, the derivative, is equal to the average rate of change, just the secant line. Yeah, so I'm going to have to find y prime. All right? And I'm going to graph this too this time. All right? So I would find y prime first. Negative 4x minus 8. You guys agree? That's parabola. You guys agree? So I'm very curious when x is negative 3 what y is. So I want to find the 2 ordered pairs. Negative 3 comma blank and negative 1 comma blank. So I actually have to sub back into the original equation. If I put negative 3 in, I get negative 18 plus 24. That's 6. 6 minus 10. I'm pretty sure it's negative 4, and I want someone to confirm that with me. I'm doing the math in my head.
So you plug in negative 3, you get 12 minus 8.
Yeah.
So that's
Whoa. I thought this was the one where you didn't need the y prime.
Ah, that's for the average rate of change. This is the mean value theorem. They're different.
Plug in negative 3, you should get more.
Negative 18.
Because
It's
are you
negative
plugging
18.
into the total? Oh,
Guys, we are putting those
I
points in
plugged the wrong
here.
one then. My bad.
We are plugging in the values here.
Oh.
That's my bad.
Because I am looking for the secant line. So I have to graph the points. And if I plug negative 1 in, oh look, this graph, it's funny this time. Negative 1 goes in there. Get negative 2 plus 8. 6. Oh, look. Negative 3, 4. Negative 3, negative 4. Negative 1, negative 4. Guys, do you guys agree this is a parabola that opened down? So everybody, what's the average rate of change for this function right here?
0.
0. I'm still going to do it all out. All right? And I want to know where the instantaneous rate of change is exactly the same. It better be at negative 2.
So why did you need the y prime and not where that came into play.
I will show you right now because you've memorized with all your beautiful studying that the average rate of change, which is this is the average rate of change, is equal to the instantaneous rate of change, which is the derivative. And I'm asking you to find the values of C that satisfy it. So I'm asking you to figure out where C is. So everybody, to solve this equation, you don't need the graph. I know I like to show the picture, but you don't need it. So what we would have done here is we'd have said, hey, -4 minus a -4, right? Over -1 minus a -3, right? That's the instantaneous, that's the average rate of change, which we all know is 0. We saw the blue line, but that's going to be 0. And that's going to equal the derivative with what value in it? C. So I think that equals -4C minus 8. So now if I go and I solve this out a little bit, I can get -4C minus 8 equals 0. Add 8 to the other side, and I get C is -2. Big surprise. That's what we knew from our graph. Does everybody agree? We saw that x was going to be -2 because that would have been the vertex of the parabola we graphed. All right. So C this time is -2. We got to be careful here. Instantaneous rate of change comes from the derivative. Average rate of change, if I just ask for it alone, is just this. The mean value theorem says when a function is continuous and differentiable, shouldn't leave off that rule, right? That there exists some point C where this has to happen. And that's what we just proved here. And then, again, in your textbook, guys, it's abbreviated MVT, mean value theorem. All right? So I'll make sure I try to get some of those in tomorrow's, too. That will not be on Tuesdays, all right? That will not be on Tuesdays, since I haven't made it yet. It's a quiz. It'll be a 20-minute quiz. You got to find some time to get in. 20-minute quiz. Come during homerooms, all right? You guys got time. Even so, we don't. So you can come up out of the office after you do announcements there, office lady. All right. All right, so you got study hall. Nice try. All right, so here we go. The next one. Everybody, the next one is the integration from -1 to 3 of -2x minus 1 dx. There's two ways to do this. There's two ways to do this. First of all, we should all recognize this as the area under the curve, -1 to 3. So we either can graph it and find the area, or do the integration. So we'll do the integration, then we'll graph it. I'm going to integrate -2x. I think it's -2x squared over 2 minus 1x over 1, evaluated from -1 to 3. I just did antiderivative of each part, right, everybody? And again, if you're not seeing that, you really got to practice some antiderivatives out of section 410. And I get -2 times 3 squared over 2 minus 1 times 3 over 1 minus. And again, I know I'm psycho. I accept that I'm psycho. I do not do much simplifying because I don't want to make a math mistake at this juncture, all right? So I am trying to be extremely careful at this point. So I get -9 minus 3, -1 plus 1. I sure hope the answer is an area under the curve of -12. How could I check it? Well, I could look at the answer key. Or better yet, let's graph this thing and see if it's the same. And you know, because if say this was a, I don't know, we're on a desert island, got all kinds of time.
This is the last thing.
This is the last thing you want to do on desert. Everybody, we are pretty good graphers of the line -2x minus 1. Do we agree? -1, -2x. And I think if I graph it, here it goes. And it's going 1 to 3. 1, 2, 3. If I plug 3 into the line, we should all see that at 3, this value is -7. And when I plug -1 in, we should all see that this value is +1. And we are going to calculate the area under curve. And I have a positive area, and I have a negative area. The hardest part of this problem is figuring out the x-intercept, and it's not that hard. My graph's a little off. There's a purple dot there. I'm pretty sure negative half is the x-intercept. That's all right. So I have a triangle on top that is only half by 1. All right, kind of annoying, right? I can see your head going back and forth like, you got to be kidding me, Anderson. But it's half by 1. Half of half by 1 is a fourth. The area of that's a fourth, positive. This triangle on the top has a 3.5 base and a 7. All right. So that is 21.5. All right. Take half of 21.5. Ugh. And I get icky. What's 21? What's 3.5 times 7 divided by 2? Hint, hint. It should be negative 12.25. You know how I knew that? Because when I take negative 12.25 plus a quarter, what do I got to get? Negative 12. All right. Both methods work. I think it's way easier in this case to integrate. All right, over here. I think this is way easier. You have to make decisions when you have these situations. But we should visually picture both these cases every time we do it. All right? Again, keep warming up, keep practicing.